Right now, we're talking about a math concept you need to know about for your digital SAT, and that's finding like bases when it comes to exponents. Here's one sample problem. Let's say we had 3 to the 2x equals 81. First off, you need to realize that 3 and 81 are powers of the same base, because 3 times 3 is 9, times 3 more is 27, times 3 more is 81. So 81 is really 3 to the 4th. So let's rewrite that. 3 to the 2x equals 3 to the 4th. Now we have a special situation that we're going to have over and over again throughout this video. You have the same base on both sides, you have both expressions equal, and therefore you can set both exponents equal to one another. So we can say 2x equals 4, and now we can just divide both sides by 2, and we'll get our answer, which is B for this question. So let's try another. Here, we've got 3 to the x is 27 to the x minus 2. So 27 is 3 times 3 times 3. So we'll replace 27 with 3 to the third. So 3 to the x equals 3 to the third to the x minus 2. And now we have to bring in an exponent shortcut because we have a power, and that power is being raised to a power. So that's called a power of a power. And in that situation, you just multiply the two exponents. So let's do that here. We would have 3 times x minus 2. Now that's a distribution situation. So that'll be 3 to the 3x minus 6. And we have 3 to the x right here. So once again, our special situation. Base is the same, expression is the same, and you can set the exponents equal. So x equals 3x minus 6. Now we can solve by taking away 3x from both sides. So negative 2x equals negative 6. Divide both sides by negative 2. And we'll get x equals 3, which is answer choice A. So here's another example. Starting with this equation here, we have to realize that 4 and 256 are powers of the same base. Both of those numbers are 2 to some power, and both of them are 4 to some power. So let's stick with the 4s just to pick something. 256 is 4 times 4, which is 16, times 4 more, which is 64, times 4, and that gets you to the 256. So this 256 can be replaced with 4 to the 4th. So 4 to the k plus m equals 4 to the 4th. And now our special moment where the bases are equal, the expressions are equal, and k plus m equals 4. Now, on the other equation, we have 5 to the m equals 25. 5 and 25 are obviously powers of the same base because 25 is 5 to the second. So let's rewrite it. 5 to the m equals 25, which is 5 to the second. Now we have our special moment. Base is the same, expressions equal. So the exponents can be set equal, and we can say m equals 2. Now we have something that we can take back over to the other equation. We can plug in a 2 right there, and that'll give us k plus 2 equals 4. Then just take away 2 from both sides, k equals 2. And the question's asking us, what is 2 to the k? So 2 to the k, that's 2 to the 2, which is 4, and that's A on this question. So coming over to our next one now, the way to start this question is to really realize that 81 and 3 are exponents of the same base. They're all exponents of 3. That's because 3 times 3 times 3 times 3 is 81. So let's start with replacing 81 with 3 to the 4th. 3 to the 4th times 3 to the x equals 3 to the y. And now we can employ an exponent shortcut for this part right here. And that's because if you had a to the b times a to the c, that's a to the b plus c. So when you have the same base and you're multiplying, you can add the exponents. That makes a lot of sense because, for instance, 2 to the third and 2 squared, if you had that, well, 2 to the third is really 2 times 2 times 2. And 2 squared is really 2 more of them. So just notice that we have 5 of them, which is what we would get from adding. And that's the reason why you do that. So here, we would make this 3 to the 4 plus x equals 3 to the y. And now we've got the same bases, we've got the expressions equal, so we can set the exponents equal. 4 plus x equals y. And what is x in terms of y? Well, we can take away 4 from both sides to get x by itself, and we'd get x equals y minus 4, which is answer choice A. Now going to another question. Once again, let's realize that we've got powers of the same base. 25 is really 5 to the second power, and that's also to the x plus 1. And 125, well, that's really 5 to the third power, and that's to the 2 minus x power. So now we have a power of a power on both sides. And the power of a power rule, that's this one right here that says that in that situation, you'd multiply the b and the c. So let's do that here. Let's multiply 2 and x plus 1, which is distribution, by the way. So that'll be 2x plus 2. And for this one, 6 minus 3x. So we're distributing in both cases. 5 to the 2x plus 2 equals 5 to the 6 minus 3x. Now we've got the same bases, the expression's equal, and we can set the exponents equal. So 2x plus 2 equals 6 minus 3x. Add 3x to both sides, and you'd get 5x plus 2 equals 6. And now take away 2 from both sides. 5x equals 4. Divide by 5, x equals 4 over 5, which is answer choice C. Now going to another example here. Here we have 128 and 32. And let's find out if they're powers of the same base. 32 is kind of famously 2 to the 5th. So let's say we had 2 to the 5th. And we multiplied another 2. So right now we have 2 to the 6th. Well, 32 times 2 is 64. Times another 2, 64 times 2, that's 128. So yes, 128 is really 2 to the 7th power. So we'll replace it. We have 2 to the 7th power, and that's all to the second, equals 2 to the 5th power, that's the 32, all to the x. So now once again, we can use the power of a power rule. And so for us, that means multiplying the 7 and the 2, and the 5 and the x. So 2 to the 14 equals 2 to the 5x, and now we've got the same bases, the expression's equal, and we can say 14 equals 5x, divide both sides by 5, and x equals 14 over 5. Going to our next question now, we've got slightly more complicated powers of 5 here. So let's try to understand this one a little bit better. If you have that situation, that's one of our exponent shortcuts that you should memorize that says that if you have a to the b and the c root of that, then that would translate into a to the b over c. So let's try it. This would be 5 to the 9 over 4. And that's equal to 5 to the 6c. So now our bases are the same, our expressions are equal, and we can set the exponents equal. 6c equals 9/4. And now we're getting c by itself. C is being multiplied by 6, so we can divide it by 6. And now dividing by a number, that's the same as multiplying by 1 over that number. That's a really important little math tidbit there. So here, before dividing, I'm going to realize that 9 and 6 are both divisible by 3. So divide by 3 here, by 3 here. And that just makes it a little easier to do the math. So we'll have c equals 3 on the top and 8 on the bottom. And that's our answer for this question. Now going to our next one, we have this kind of complicated expression here. And the question says that that's all equal to this. So we'll take it one piece at a time. So 144m. And what's the power that goes on that? First of all, the rule is this one right here. If you have a to the b, and the c root of that, that's a to the b over c. The problem here is we only have one of those numbers. We have a number right here, but what do we really have right here? And the answer to that is easy. There's an invisible number 1 around the whole 144m. So that's 144m to the first power. Knowing that there's a 1 there allows you to realize that this is 144m to the 1/5. So we'll write that here, to the 1/5. And for this one here, same idea, that's 144m to the 3/6. But I'm not going to write 3/6 if I can write 1/2. So 144m to the 1/2. The original question said this is all equal to 144m to the 9x right there. So what do we do now? Well, this is a much more complicated version of this situation here. So we need to add the exponents. So let's go ahead and do that. We'll have 144m to the 1/5 plus 1/2. Still equal to all this stuff on the right. Now, I definitely think you should be able to find like denominators and add this on a paper. But in the interest of being able to handle harder questions, let's show you how to add these fractions and get your answer in fractional form using Desmos. So here we are on the Desmos graphing calculator, and I'm going to go ahead and enter 1/5 plus 1/2. That'll naturally give me a decimal, but this button right here, if you click it, turns it back into a fraction, and you get 7/10 there. So this is all 144m to the 7/10 equals 144m to the 9x. So now we've got our identical bases, the expressions are equal, and we can set the exponents equal. We can say 7/10 must equal 9x. Divide both sides by 9 to get x by itself. And like I said, dividing by a number is the same as multiplying by 1 over that number. So here you have cancellation, and x equals 1 times 7 over 9 times 10. 7/90. And that's our last answer. Thanks so much for watching our lesson on exponents like bases, and we're going to be trying our best to produce new lessons every day. And these lessons are coming from the things that we're noticing in our tutoring are some of the cutting edge concepts on the SAT. So we hope you enjoy. If you have any comments, let us know. Have a great day.